Good afternoon, everyone. So, in today's session, we will discuss about the internal one data science paper, section A. So, my name is Ravi Jaiswal, MTech fifth sem student. So, let's begin with question number one, in which it is stated give three commonly used statistical measures to characterize dispersion in complaint derived scores. Example: alleged offensive severity, evidence strength, harm impact index. Discuss how these measures can be computed efficiently over large complaint repositories. Example: partitioned stores, streaming aggregations, approximate sketches. So we have to discuss three statistical measures of dispersion in this question basically. So the first one is standard deviation. And so what it measures? It measures how far complaint scores, severity, which were given in question like severity, evidence, strength, harm index spread from the mean. So we all know the formula of mean is which is the sum of all the values divided by the number of values, and the variance is calculated as the difference of squares of all the values of a data set divided by number of values in the data set, and the standard deviation will become the square root of variation. So why we use this standard deviation term? Because it is useful when data is roughly symmetric. It also shows overall variability around the average, sensitivity to all values, so it captures even small changes in complaints. The next one is interquartile range. It measures the spread of the middle 50% of score, and it is measured as the quartile 3 minus quartile 1, where quartile 1 is 25th percentile and quartile 3 is 75th percentile. Why we use it? Because it not affects by extreme values, good for skewed complaint data. Example: some complaints extremely severe, and it shows central spread more reliably than standard deviation when outliers exist. The third one is mean absolute deviation. It measures a typical deviation from the median. Why we use it? Because it is very robust to outliers, good when complaint scores, when sudden jumps or heavily tailed distribution, often preferred our standard deviation for noisy or irregular complaint data. So let's move next question, which is we have given sorted data from 13 to 70, and we have to solve A to G questions in it. The first one is mean score and median. So we all know we will add up all the values. It becomes 789 divided by number of 26, so it becomes 30. The mean becomes 30. Median is the, so as the data is even, so medium is the sum average of the 13th and 14th values, so it becomes 27.5 when we divide 25 plus 30 by 2. The next B part is what is the variance mode and standard deviation. So we already discussed the standard deviation formula, and with this formula we get the value as 13. So the variance is 170, and we will do square root of it, then it will become 13. And the C and D part is mid range and quartiles. So mid range is nothing, basically the minimum term, which is 13, divided by the maximum term 70 divided by 2, so it becomes 41. And quartile is the lower 13 values and upper 13 values. Once we divide the data sets into two halves, then we will take the median of the first half, which is the seventh value, which is 21, so it becomes quartile 1. And the next part is the median of the next second half of the data set, which, and it becomes quartile 3, which is 35. and the fifth one is 5 number summary. So 5 number summary is nothing but it is basically minimum value 13, quartile 1, median, quartile 3, and maximum value. Now we will have to draw a box plot for this data. So how the box plot is basically designed? So we will measure the score on the y-axis, and we will draw a scale from 10 to 70. Okay, draw a blocks from 21 to 35. Why? Because the 21 is the quarter one and the 35 is quarter two, so we have to draw box between these numbers. And we will draw a line inside that box. Why? Because the median, which is 27.5, is lie between the middle of the box, and which is shown by the red line. Draw whiskers from 30 to 13 to 70. 13, because 13 is the minimum value and 70 is the maximum value, and 17 may be computed as a high score value. So this is all about box plot. Now let's move on next question, which is quartile plot versus quantile plot difference. So what is quantile plot? We will first see, which is x axis ordered complaints, y axis quantiles scores of the data itself. The quantile plot shows distribution shape, skewness, spread, and the quantile plot compares two distributions. X-axis is theoretical quantiles, example normal target model. Y-axis is data quantiles, example evidence scores. If point lie near a straight line, then data roughly follows the target distribution. Useful to check DSS assumption through evidence strength distribution. Now, friends, let's move on next question, which is we have also given the data which is in the form of class range, and we have to compute the median of it. I will write the short form, approximate median of group data. So this is the formula. On the basis of it, we will calculate all the values. The formula is L plus n by 2 minus CF divided by F into H. L is the lower boundary, which is 21 in this case, and n is the total sum of all the values, which is 3194. CF is cumulative frequencies, so we have calculated this here: 20, 200, 650, 950. H is the difference between the class, which is 30. So we will put all these values in this median formula. So the formula becomes 21 plus 1597 minus 1950 divided by 1500 into 30, and we will calculate it. So the approximate median severity will become 34. Now the next question is question 4. A district intake sample records complaint age and self-assessed incident impact percent for 18 complaints. So we have given the age section and the complaint sections for the district, basically a district area. We will have to compute the mean, median, and standard deviation for both the age part and impact percent part. Draw box plot for both, and draw a scatter plot and QQ plot to study the relationship between this age and impact percent columns. So the we will first see the median and SD of age. So the mean of age is sum of ages divided by number of ages, which becomes 46 around, and the median is the average of ninth and 10th values, which will become 51. Standard deviation is nothing but I we have already discussed it. It is repeating again and again, so it becomes 13.7 years. Now we will see mean, median, and SD of impact percent. So the so it is as the unit is percent, so the data is also coming in percent. So the mean of a percent impact percent is 28, and the median is 30, and SD standard deviation is 9.3. So we will do the blocks plot for it. So we have already discussed that for the lower box plot line we have to calculate quartile 1, and for the upper box plot line we have to calculate quartile 3. So here as the data suggests, the quartile 1 becomes 21, and median we all know that it is 15. So and quartile 3 is 57. For the age we will talking about age currently, and the box will go from quartile 1 with that is 29 to 57, and the line is at 57, and the whiskers are at minimum and maximum, which is 23 and 61. So this is the box plot for age, and the box plot goes like this. This blue line indicates the median, this upper and lower line indicates the whiskers, and this box indicates the quartile 1 and quartile 3 range. Similarly, we will do the box plot for impact percent. So the data for impact percentage is also shown here, which is the lower quartile range is 26. We can see the data from here also. The upper quantile range is 34, and the whiskers lie between around uh, 18 to 42. So this is all about the box plot of impact percent. So we have drawn it, and now we will see the scatter plot and QQ plot. So scatter plot is on x-axis we will represent as H, and y-axis represent as impact percent. Each point one complaint. Whenever we draw, we point each point, it means there is a complaint there. Visual check older complaints tend to show slightly higher impact scores, mild positive trend. Now we will check the visual check through the graph. So let's move on the graph. So this is the graph, and it is a scatter plot, impact versus age. So here the first yellow cross we can see here, it is between 20, 10 and around on x-axis it is 20. So this is the first complaint we have, and the next complaint is between around 27 to 20. In this case we have all the complaints between age versus impact of graph. So that's all for this internal one paper. I hope you all understood this, and let's move on to the next video. Till then, bye bye, take care, thank you.